Good. Good morning and welcome to the fourth class. In the end of this week, we will have half of the lecture. So we have a lot of work in front of us. So now we hopefully finally you have kind of understood how this lecture works here. We have started getting into the things. What is Internet of Things? How strangely it is defined, so how many areas it covers. We have talked about the hardware buses. We talked a little bit about story-driven model and story-driven development. So sorry that this week there is not so much, but don't worry, next week we will all start being totally into stories. And we talked about Internet of Things, exchange formats and protocols. So there will be a small exercise to start with, but don't worry, today there will be a big lecture part. So after this small exercise, we will watch actually 3 parts of a lecture together and analyze the lecture from somebody else. It's on Internet of Things, so don't worry. So I've talked with you in the lab, and you have done some very repetitive tasks in the lab already. And some of you have gotten a grasp that maybe doing that with 1,000 microcontrollers might get very tedious, what you have done so far. So I want you to think about both scaling up and testing. So what will happen if what you do now in the labs you have to do for lots of devices, maybe roll out to a customer? So what is missing there? And how can you make sure that the quality is okay? How can you do some testing in there? In this, because we have talked about these simulators and about MQTT using some standard protocols and about stories. So what role will these artifacts play? So what role will simulators, MQTT, and stories play for scaling up and testing? So you don't need to Google now. I actually want your personal opinion. So I want you to talk with each other to prepare for a discussion we have after this together. So 10 minutes, I want you to discuss and think with your neighbor, and of course write down at least 2 points per each, So you probably will come up with more, but at least that you have a little list of things we can use as a base for discussion. Okay. Scaling up and testing. Also think what happens if we increase the number of devices. Think a little bit about features you would like to see and how can these things you have already seen help you with achieving these goals. 10 minutes. So what I actually forget is here, what would you like to see for scaling up? What is not so great currently? You all wrote down your problems and mistakes, and if you imagine you have to do that for a big system, you might want to avoid these things that happen, and you might have a feeling now already what can go wrong more often. Okay, I see there are some pretty good ideas. Let's go to the answer part, and I need to, because I changed that, to make a copy of this. So in general, what will be the issues? I've heard tons of issues.
Scaling up will greatly increase the overhead.
So overhead in terms of what? Bandwidth or?
Bandwidth and necessary time per person.
What time?
Time per person.
person. If you do it all manually, yeah? Bandwidth and manual configuration. Okay, then my first issue, so it was actually against my lecture, but I think your point is really valid you had there. The group of three here, you said that documentation is lacking, and you want more, you think you need way more documentation of the frameworks, yeah? Morgan, other issues? You had some pretty good points.
We need faster connection to our servers or devices.
Faster connections.
Faster connections, yeah, and you also kind of hinted at privacy security. Okay, I think anything else, kind of other issues?
Finding defects devices.
Finding defects, especially inside an integrated system, yeah? Because there was a point raised back there too. What about mass deployment? I think nobody of you had that. So what if I need to make an update for 10,000 devices? Then I have to go to the customer, collect them, connect them to my computer, and reflash them? Okay, I'm just writing down mass deployment, but then you know what. Can you still read anything? Okay. So testing. How can we do testing?
Stress testing with tools. So to send a lot of requests to the server and to stress the server capacity.
Okay, have some kind of simulation environment and there do the stress testing. Yeah. Simulation. Stress testing. Other things. So there were some of you were kind of talking about the simulation environment. Oh, here first.
Integration testing.
How?
And so that we every day probably test one device. So always at 3 o'clock, then midday, in the afternoon, we test everything.
Time. So kind of make a discipline for testing. Yeah. A test strategy. But what is your base for the testing? So how, because if you do some kind of manual test, you need kind of a test manual or kind of something which describes the test, the steps how to test. What is the base for creating these tests?
Unit tests.
No. Of course, on the server, there are things we can unit test and stuff. But especially in the Internet of Things, the whole unit testing becomes very, very difficult. So that's actually an issue. Why? Why is unit testing so difficult here?
Because there's too much we should test.
There's too much hardware involved. Yeah? So you want to test the hardware, but the unit tests are usually just software entities you test in a very defined environment. Yeah, so if you can invent a system for our hardware unit test, that happens. You have kind of little robots which press buttons and so on. You could say that is kind of unit testing on the hardware level. But the problem is we have a hardware system. We have a system of sensors, actors, and then unit testing is very hard. But okay, when can you do unit testing? Actually, good point. What do you need to do unit testing? So what role do simulators play? You could actually have all the components run by simulators and just test one component against the whole system of simulators. Or if you have only simulators, then you can do unit testing. So the simulators we are just building play a huge role in testing. But what I wanted to hear for testing, and we discussed that a couple of times, so think about the stories. Don't the stories help us with testing? Or at least making the test manuals?
Yes.
So then stories also base for testing. So in how far, also here also stories. What else would you like to see for scaling up? What kind of help by the system, apart from documentation and mass deployment? Is there anything else where you want support from the framework you are going to use? You're all happy, great. Everything works. Why don't you build your company right now?
Collect as much log messages as possible, maybe.
Collect as much message, some kind of data analytics, or
Messages. Log messages.
a log system. Very good. Or logging systems, system monitors. Very good. What about user interfaces? Are you happy with the user interfaces you use so far? What about some support to do nice dashboards and all the data you collect in the logs, make it to visualize this? MQTT. How can MQTT help you with all this mess? It doesn't. So what's good about MQTT? It's kind of a standard, yeah, for machine-to-machine communication. So it might make it easier to talk to other people.
We can make a chatting server.
Yeah, no, but you can kind of use it for putting your logs in a default system or so. It's really easy to integrate other components, existing systems with it. So MQTT should help you in integration. Standard definition. What about the security issues? Isn't MQTT a good solution? It brings all the bells and whistles for security and access control. So yes, it helps you with security. What about resource consumption? Somebody of you said, okay, yeah, you said actually that there's too much, might be too much bandwidth. So actually MQTT is a pretty lightweight protocol, so it actually helps with the resource management. Also, MQTT helps you with kind of guaranteeing that messages arrive. So also quality of service is in MQTT. Security, quality of service. Good. Anything I forgot? Anybody has some points we need to add? No? Okay. Then, as a reward, you get a little lecture. So, there is another lecturer who works as a consultant, Kai Wähner. He does some really nice presentations on Internet of Things. And I've used his video a couple of times. So this, we will do this in 3 parts, because I don't want you to just consume a lecture. I want you to pay attention during that. So on your computer, kind of open somewhere at your text sheet and these points. So in the beginning, I want you to find answers to the questions which are listed down here. Yeah. So what are we get a little bit of an introduction to IoT in general again, so it's a good repetition for you. The first 10 minutes is kind of about that. And then we go to frameworks and integration. So what are the key challenges of Internet of Things and why? Yeah, so make some keywords for that. What are the generic solutions for these key challenges? So what is the abstract methodology or abstract thing that can solve that? They will talk about patterns in the beginning, so I want you to capture at least 2 examples for potential patterns to deal with the problems. Again, there is everybody has a definition of cloud, edge, and fog, so try to capture the definition of the presenter here. I think it's close to mine, but you can disagree. And then I want to have 2 advantages of edge or fog computing versus cloud computing. So let's watch that. Okay, so that was the first part. And what do you think? We're pretty good, aren't we? So a lot of the things he's presenting we have discovered already. Especially now in the discussion, I've seen a lot of the things you have there. So let's kind of do a quick recap. So what's the key challenge? Or what are the key challenges? Or what's the main one?
Integration.
Integration. Yeah, so it's all about integration. So we will see that even as the key challenge of this class. Yeah? What were other challenges?
Different IoT platforms to connect.
So kind of the diversity, the fragmentation, yeah? Other challenges?
Lots of standards for different levels.
Mm-hmm. This is all your kind of integration. So anything else about problems he's mentioning there? Well, connectivity, he also mentioned, is one of the main challenges of the Internet of Things. And based on connectivity, bandwidth, latency. Okay. What is the generic solution for all of this?
Good IoT standards.
I don't think that he said that, but you can prove me wrong. Okay, he says probably somewhere, but I missed that one. I was actually targeting as something else. What does he present as the class of frameworks or platforms which will deal with this?
Hybrid integration platform?
Yes, I was thinking about the hybrid integration platform. So this hybrid aspect is, I think, something he brings here, which I also tried to hint at when we talked about cloud, edge, and fog computing. So talking about that, what is his definition? How does he see the 3 in contrast to how I defined it? And some of you have mentioned that when they did the research here in class already. Are there 3 different things for him? Cloud computing, the edge, and fog computing? Or is there some gray area here? I thought you should be... So I have the feeling that Kai Wähner treats the edge and fog computing similarly, kind of on the same level. Even if he first describes the cloud, then he describes the edge, and then he kind of says there is some kind of fog computing going on. So it seems like the fog is another step, which would be similar to the definition I said, but then he said if we compute on the edge, we call it fog computing. So be careful, not everybody has the same definition here. But however, he has the same point as I. It's important to do some computation on the edge. And that has a lot of benefits. So what benefits? Did you catch some? What are the benefits when you do computation on the edge?
Local control.
Local control. What else?
Less traffic to the cloud.
Less traffic. Anything else? I guess that was the main points. Great. Okay, at least I have to quickly explain the points you want to look out for now. So we continue with the movie. Please try to capture the different categories of the presented frameworks. Then what are the main features in each category? And also try, because I love examples and he gives quite some, so try to also catch 4 or more examples of applications and 4 more examples of available tools. This will make sense when you watch it. Yeah, so categories, features of categories, examples of applications, and examples of tools. And I forgot to remove this point from the slide, so this is actually valid for the next one. So at the end, I will ask you something about your opinion about which framework you like best. You can already start thinking about it, but this is actually valid for the next part. Good. So that was the second part. And so you're probably all prepared to see the third, but let's recap very, very quickly because we're running out of time. So I'll remove that here now. So different categories of frameworks. What did he present? What was the first category?
Data pipeline.
Data pipelines. Second category?
Data processing. Stream processing.
Stream processing. And third, maybe somebody else?
Process engine.
Process engine. Okay, that was the 3 categories of frameworks he presented. Do you remember some of? No, let's. Okay, what are the features of the category? So, data flow. What are the features?
High throughput.
Throughput, A to B, kind of applying things to each data sample which is coming through. So stream processing, what's the difference to data flow?
Machine learning.
Well, can be used for it. There was an example, yeah. But the data flow is more like correlating lots of streams and kind of seeing in a sliding window what is going on there, yeah? And then we have the process engine. Logic at the edge. What does it add? Retrying, rerouting, resuming, a bit more process flow than with the others. So it has a more integrative character. Examples you remember of applications? Only the last ones, yeah? The problem of the lecture.
Apache, IBM, Storm, Global.
Yeah. These are also the things you need to remember because we will come back to them. Here, stream sets, cask hydrator. We have used in the stream processing like R, Spark, MATLAB, all these kind of math tools. And then we have the ones you just mentioned. So what are kind of example applications? There were a lot just before here. In one of the last slides, he showed all these use cases. Device management, device registration, usage billing, all these things, yeah? What in the stream processing, there were some really nice examples. Remember? He was talking explicitly about one. And we might come back to that. There's a very, very common example for the Internet of Things. Predictive maintenance. Yeah, predictive maintenance. So if you want to build something cool at the moment, I think if you can offer a predictive maintenance solution, especially in the area of green energy, so we talked about the wind farm example, you can actually use kind of lots of sensors to detect if you have to send somebody to repair the machine in advance before the machine fails. But also in factories, predictive maintenance is an example that is used a lot. Okay. So that we will probably run a little bit out of time. This is why I show you first the lab. So today we will replace the simulators we built last time with physical things. Yeah, so you have built the MQTT simulators, and already last time some people misunderstood me and started building it for the ESP. So today we will actually do that. So basically build a physical temperature sensor so that you learn something new, use a different temperature sensor. There's a DS18X20 in there, so use that. If we don't find it for you, use the DHT11, but try to find in your blue box a DS18X20. It's a little black, looks like a transistor, but is a temperature thing. And I can show you one in the lab and use that for connected to the ESP. And then there's a relay. There's a real relay switch in there, so you also want to connect to a different ESP relay switch. So really, and then you can kind of check their functionality, so you can try out a little bit of testing directly with MQTT-FX, and then you can integrate it with your integrator. I think the third task we might move to the next time, because I won't give you a demo for Node-RED yet, so let's move that to the next time. But if you have time today, start working with an RGB. So kind of build up at least the ESP and send with MQTT-FX color data to the ESP to set the color of the RGB. And then the Node-RED stuff we do tomorrow. And let's go here. So he will present the IoT frameworks. So I would like you to catch 3 common features of the frameworks he presents. Then the target audiences. So there are different user groups for these different frameworks. Developers can use them all, but sometimes he says that other people can also use these. Then he will present advantages and disadvantages, try to capture some of them. And then how are these related to the cloud? Yeah, what is available in the cloud for usage with this? What is the characteristics? And where do they fit? Are they on the edge? Are they in the cloud? So where are they usually deployed? And also think about which one is the coolest of the 3 he presents. Yeah, so make an opinion what you liked best and think you would like to use. So before you get nightmares about people clicking on mousepads, I will stop here. And so he will now finish up comparing the 3 and giving some final remarks. But I think that's a good place to stop. So any takers? Who wants to continue working with Cura? Who wants to do some work with Node-RED? Nobody? You all want to use Flogo? Okay. I have to disappoint you. You will do more work with Node-RED and less with Flogo, but the good news is you will do some work with Flogo in this class. So see you in the labs, and next lab we will start with Node-RED.